This video is about finding the perimeter or circumference and area of some common geometric shapes: squares, rectangles, triangles, circles. If you feel pretty comfortable with these ideas, feel free to go quickly through this video. If you're not so familiar with them, then by all means take your time, because these are some important ideas that we'll hit several times throughout this year. Now I want to show you where these formulas come from, not just give you the formula. Okay? Here's a square, and I'm saying that one side of the square is length s as a variable. Now the perimeter is the distance around the outside of the figure, and so the distance around the outside of the square. Now there are 1, 2, 3, 4 sides on this square, and they're all length s. So the perimeter is equal to 4 times s. Now area is a little bit more tricky conceptually. So the way you find the area of a figure is how many unit squares, square inches, square feet, square centimeters, how many unit squares will fit inside of a shape. So let me show you. I'm going to say this is a 3-inch by 3-inch square, which means on one side there are 3 inches. So each of these is an inch. And on this side, again, there's 3. So how many 1-inch squares do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, which happens to be 3 groups of 3, or 3 times 3. Now that'll happen for any number s. It'll always be s times s, because you'll always have s groups of s squares. So I can simplify s times s as s squared. So the area of a square is the side length squared. Now let's apply that to a problem to see how that works out. Find the perimeter and the area of a square with side length of 7. Well, the perimeter is equal to 4 times the side length, or 4 times 7, which is 28 inches. And the area is equal to s squared, or 7 squared, which is 49 inches squared. Okay, I hope that helps. Let's move to a very related idea about rectangles. Now, for the perimeter of a rectangle, this length is different than this length. Okay, but you'll notice that I have, let's see here, a B here, and this is also the same as B, and an H here, and this is also H. So there are 2 ways I can think about this. The most straightforward one from the picture is that the perimeter is equal to 2 times the base plus 2 times the height. Now, sometimes in books you'll see that they've actually factored out the 2, or thought about, this base times height, that length, it's doubled, or 2 times base times height. Sorry, base plus height. Okay, either formula would be fine. I tend to use this one because it makes more sense to me from the picture, but you can use either one. The area goes along with the idea we talked about before about how many unit squares will fit inside of the shape. Okay, this way there will be B groups of H unit squares. So it'll always be B times H. So the area will be base times height. Okay, let's look at that in a problem. Find the perimeter and area of a rectangle with a base of 9 and a height of 5. They didn't give us any units, so we'll just work with it that way. The perimeter is going to be 2 times the base plus 2 times the height. Now 2 times 9 is 18, 2 times 5 is 10, and so I get 28 units is how long the perimeter is. The area, let me scroll down a little bit. The area is going to be base times height, or the base is 9, and the height is 5, or 45 units squared. Okay, let's move on to the next shape, is a triangle. The perimeter of a triangle, again, is the distance around the outside of the shape. But I know all three lengths. This is A, this is B, and this is C. So the perimeter is equal to A plus B plus C. Pretty typical. You just add up the three sides of your triangle. The area is a little bit more complicated, and before I can explain why it is the area is base times height divided by 2, we would need to talk about how to find the area of a parallelogram, which we're not prepared to do. So I'll just, remind you that the formula is base times height divided by 2, or 1/2 base times height. We'll be able to derive that later on in the year. So find the perimeter and area of this triangle. The perimeter is what I get when I add the three sides together. 5 plus 7 plus 4, and that is 16. Yes. And the area is equal to base times height, 7 times 3 over 2. 7 times 3 is 21 divided by 2, and I get 10.5. All right, finally, a circle. The circumference of a circle is the distance around the outside, just like a perimeter, but we only use the word perimeter for polygons, and we'll get more into what a polygon is later on this year. But we use the word circumference for a circle. Okay, and again, I'm not ready to derive where this formula comes from, so I'll just say this. The circumference is equal to pi times d, or 2 pi r. Both are useful depending on if you have the diameter or the radius. And the area of a circle is pi r squared. I think on Pi Day we'll talk more about the number pi and why it works out so nicely in these formulas. Find the circumference and the area of a circle with radius of 3 feet. For the circumference, I have the radius, so I'm going to use this formula. 2 pi the radius, which is 3, and I get 6 pi. And I'm fine leaving it in terms of pi without plugging it into my calculator. So I'm going to say 6 pi is the circumference. The area is pi r squared, or pi 3 squared. Now 3 squared is 9, so I have 9 pi is the area of my circle. Now here are these ideas as it says in your textbook. Go ahead and double check your notes, make sure you have all the formulas written down correctly. If you want to pause this and copy this down, that's great, but I'm moving on. Okay, the last idea I want to hit on before we leave this section is the idea of the area addition postulate. Now it's a postulate. It should make a lot of sense without me having to explain why it should work. Okay, the area of a region is the sum of the area of its non-overlapping parts, which means if I can take a shape, now this shape is a kind of an interesting shape. I don't have a formula for this shape, but I can cut it up into parts that I know. In this case, they have to be rectangles, but they can be any shape as long as I know what they are. So I can cut them up into non-overlapping parts and find the area of each of the parts and add them together. So let's do this one. Here is an interesting looking shape. Okay, and if you look at it, you can either cut it this way and get a trapezoid and a square, or you can cut it this way and get a rectangle and a triangle. Now, since we haven't covered yet how to find the area of a trapezoid, I will stick with this way. Now, this is a rectangle, and I have just learned that the area of a rectangle is base times height, which is 12 times 4, which is 48 square feet. Okay. Now, because of this tick mark right here, same as this one, I know that this is the length of 4. Okay. But finding this length is a little trickier. Okay. I will have to use the fact that this is also a tick mark, so this length must be 4. And this entire length is 12. So what they've done is that this is they've taken 12 and they've subtracted this length of 4, and I'm left with a length of 8 feet. Okay, so this triangle has a base of 8 and a height of 4. So this area is base times height divided by 2, or 8 times 4 divided by 2. And 8 times 4 is 32 divided by 2, or 16 square feet. Now, I'm not done. I found the areas of the non-overlapping parts. Finally, I just add them together. So if I add these two together, 48 plus 16, I get 64 square feet. Yes, I get 64 square feet. Okay? So we talked about how to find the area of squares, rectangles, triangles, circles, how to find perimeters of squares, rectangles, triangles, and the circumference of a circle. We also talked about how to find the area of, using the area addition postulate. I hope this was helpful for you.